I've been having major technical difficulties with my recording stuff here. I'm working on it. I have a tech ticket in. Like, I'm recording right now, but I wasn't able to record yesterday or last Thursday, so I wouldn't let me. So, you know, you are going to have to depend on the notes more than the video on some of those days that you're absent. And yesterday we learned something very new. I'll be reviewing it pretty quickly here and then adding on the new stuff, okay? So one of the things we learned about yesterday is rational functions. It's like a polynomial on top and a polynomial on the bottom. And we went through all the different steps. So if you didn't get the notes from yesterday, you're going to need to get those. And then, so one of the very first step on all rational functions is to factor the numerator and or the denominator if it's factorable. Sometimes it's not. Sometimes only 1/2, sometimes both. It just depends, but that's the first step. So this is why I've been hammering it into you all year, that factoring never goes away, okay? Any math you take after this class is going to have factoring in it, solving equations, certain things you have to know, okay? So that's why I've made a big deal out of it. And factoring keeps popping up through different lessons throughout the year. And here it is again. So this is a chart problem, as you hopefully remember. We're asking ourselves what two numbers multiply to get -8 and add to get -2. What are my numbers? 2 and 4. Which one's going to be negative? Yes. Yeah, you're right. Does it matter, Sarah? Yes, it matters which one is negative. You can use a calculator on everything in here. So there's no reason for you to get signs wrong, okay? 2 plus -4 equals -2, and 2 times -4 equals -8. Okay? So we have x plus 2 and x minus 4. Any order, right? As long as the 2 is positive and the 4 is negative. All right, now I'm going to leave this space over here to do the graphing, but let's organize our information for our key features. This is what we learned yesterday. We're going to identify the whole, the VA, the 0, and the HA. Now, there's no rule about what order you write those in, but it's pretty much the order we find them in, so that's why I use it that as the order. Okay, so remember, we factored. Great. Next step is to see, are there any like or identical factors in the numerator and the denominator? Yeah, right? X minus 4 is on top and x minus 4 is in the bottom. So we're going to cancel those. The 0 of that factor, meaning when I set that equal to 0 and solve it, is 4. I'm going to have a whole at positive 4. And yesterday we just identified these things. We didn't see what it looked like on a graph. Today you'll finally see what is this whole she keeps talking about. Okay? Then vertical asymptote is any factors left in the denominator. Is there anything left in the denominator that didn't get canceled? No, there's nothing left. So we have none. There is no vertical asymptote. Zeros are whatever's left in the numerator. Those are going to be your x-intercepts, which you'll see finally today. We set x plus 2 equal to 0 and solve it, and we have a 0 at x equals -2. And then the horizontal asymptote, that was, I told you, probably the hardest part of this, something you're going to have to like memorize. We determine this by the degree of our numerator and the degree of our denominator. So if you need to pull out yesterday's notes to see that, there's a 2 on top and a 1 on the bottom. 2 is greater than 1, right? The degree on top is greater than the degree on the bottom. That means we have none. Anytime the top is more than the bottom, you will not have a horizontal asymptote. Okay? So what we're going to do is, there is one step left that we didn't talk about yesterday besides the graphing, but what we're going to do is put our key features on the graph first, and then I'll tell you what your last step is to get your graph. But it's much easier to have a sketch of the graph first. Okay? So I'm going to just draw myself an XY axis. Let's go ahead and I'm going to hold off on the whole. Okay, so hold off on the whole. Okay, I know I'm going to have a 0 at x equals -2. Remember what a 0 is. A 0 is a x-intercept. It's going to be right here. Okay, I know my graph, whatever it looks like, is going to hit the x-axis at -2. So that was that. I have no vertical asymptotes. I have no horizontal asymptotes. Now I am going to have a hole at something called x equals 4. We're going to hold off on that. Hold 1 second. Look and see what you have left. After we canceled it, all that's left is just x plus 2. That's what's left, x plus 2. Everything else canceled. What type of graph is that? Linear. Very good. Who said that? Carol? Good job. X to the first. This is a line. Now you can make an XY chart if you want to. You can use slope-intercept form. Let's revisit slope-intercept form. If we have a y-intercept at 2 and then a slope of 1/1. Okay? But don't forget, and you know that slope goes on forever and ever. See, it even hits this x. I mean, you could keep going like that forever and ever. So there's our line. But don't forget this whole thing. There's a hole at 1, 2, 3, x is 4. Wherever your graph hits x equals 4, you will have an open circle. So because this is 4, there's a hole on our graph at that number. That's why you want to wait till you graph a line, or whatever it is you're graphing. They're not all going to be lines. You're going to see this is a little bit of an easier one. That's what will happen there. Okay? Let's try another one. Yep. So remember slope-intercept form looks like this. So M is your slope and B is your y-intercept. So my y-intercept was 2, right? B was 2, so that's where I got that. And then what's in front of the x would be a 1. So you could call it 1/1. So I just went up 1, right 1. Good question. Sorry, I should have put it up. Okay. These take practice, and they're not all going to look the same. Okay. You have to look at what you have. Okay, so let's go to the next one. Let's practice some more, and then I'll do some of the homework with you. First step is to factor. Is there anything that we can factor in this numerator or this denominator? No. So yay, you don't have to do any factoring. Let's organize the whole VA, 0, and HA. So remember how we get a whole. A whole comes from any numerator and denominator that are identical twins, and they cancel. Do we have that in this problem? Is there anything that cancels? Nope. So we have none. Okay. The vertical asymptote is any factor left in the denominator that didn't get canceled, right? We have x plus 1. We didn't do anything to it. It's still there. Set it equal to 0 and solve it. We have a vertical asymptote at -1. Your 0 is anything left in your numerator. Well, we didn't cancel anything, so there's clearly something left in the numerator. Set that equal to 0, and we get 3. And the last part, this memorization part, is looking at the degree of your numerator and the degree of your denominator. Remember, degree is your biggest exponent. When they are the same, you will have a horizontal asymptote, remember it's always hay and backs, at whatever the leading coefficients are. So it's 1/1. 1/1, which is 1. So this graph's a lot different. In the last one, we had a hole but no asymptotes. This one, we don't have a hole. We have 2 asymptotes. Okay? So first step is to put these items on the graph first, and then I'll tell you what else we need to do. Okay, we have an x, so understand what a 0 is. It's your x-intercept. At +3, our graph is going to hit the x-axis at 3. We're going to have a vertical asymptote at x equals -1, and a horizontal asymptote at y equals 1. So now we have to figure out what this graph looks like. What it's going to look like is very, very similar to the ones we just got done with in reciprocal functions 9.3. Remember we had like the branches, the curvy ones? Looking at this graph, I know I'm going to have a curvy in this quadrant right here. I know because I already have a point there I'm going to have a branch, they're called, in that little quadrant marked off by my asymptotes. I just need to find where the other one is. So what I'm going to do is pick a number that should feel familiar, in this case, to the left of this asymptote. And that's going to tell me where my other branch is. So I have a vertical asymptote at -1. I'll just use -2. So I'm just plugging -2 right in here. So that would be -2 minus 3 over -2 plus 1. Use your calculators if you need to. And that's all we need to figure out our other curve. So we start at 0, 0, always graph at a point. We go left 2, up 1, 2, 3, 4, 5. So putting that point there shows me I'm going to have a branch in that quadrant, and that's all I need. So that's why you want to put your points, everything you have on the graph, just like we did with reciprocal functions. We put our VA and our HA on. Remember, I'd highlight it pink and yellow. And then whatever you had, then you picked a point to the right and to the left of your asymptote. So every graph's going to be different. So if you put everything on there, then you can see, okay, I just need one point to the left of this to figure out where my other branch goes. All right, let's practice one more. Sorry, I was writing this from like the side of the, I was reaching, a little messy. X plus 1 over x squared plus 6x plus 5. First step is always to ask yourself, is there any factoring? And there is, right? We can factor this quadratic trinomial. It's a chart problem. So 1 times 5 is 5. Middle number is 6. There's lots of numbers that multiply to get 5 and like kind of add to get 6. Well, 2 sets, 1 and 5 and 2 and 3. It matters which one you do. Are we going to use 1 and 5 or 2 and 3? 1 and 5. 1 and 5. Here's why, guys. 1 times 5 is 5. 1 plus 5 is 6. If I use 2 and 3, that wouldn't even work, actually, because 2 times 3 is not 5. I don't know why I even offered that. 5 only has those two factors, so it better work, right? 1 times 5 is 5. 1 plus 5 is 6. And guys, use the numerator as a hint. When you factor, something's going to cancel. So probably one of your factors is going to be x plus 1. Okay, so that's kind of a good tip. All right, let's set up our key features, all of our important stuff, whole, VA, 0, HA. So we get ready to go. We've factored already. Anything cancel? Sure does, right? X plus 1s cancel. That gives me a whole at x equals -1. If you cancel, you're a whole. If you want to grab some graph paper, Evan. If it's left in the denominator, it's a vertical asymptote. Well, we've got something left in the denominator, so that's -5. JT, you're so sweet. Thank you. Remember, if you cancel, you're a whole. X plus 1 and x plus 1 cancel. It's none when nothing cancels, like in the last one. When nothing cancels, there's no whole. But if there's a factor that's identical in the numerator and the denominator, they cancel each other out, and that creates a open circle, we just call it a whole, at that x value. Whatever's left in the denominator, if there is anything left, that's your VA. And anything left in the numerator would be a 0. There's nothing left in the numerator. This would be none, not 0, okay? None. The only thing left is the HA, the horizontal asymptote, remember. Look at your notes from yesterday. Look at your degree of your numerator, which is 1. The degree of your denominator is 2. 1 is less than 2. When that happens, you have a horizontal asymptote at 0. So there's only three options. No horizontal asymptote of y equals 0, or when the top equals, I should have written it here, when 1 equaled 1, if they are the same, then we look at the coefficients. Okay, so that's in your notes from yesterday. All right, so let's start by sketching this graph. Now I see I have to go all the way, x is -5, so I just want to make sure I give myself enough space to go to the left that far. So I'm just skewing my graph to fit on my graph paper. Okay, remember we are going to save the whole for later. And then you should jump in with us. We have a VA at 1, 2, 3, 4, -5, right? We have a vertical asymptote at -5. We have no x-intercepts. That means our graph isn't going to touch the x-intercept. That's okay. No big deal. And we have a horizontal asymptote at y equals 0. So horizontal line goes like this. And I just highlighted it so you could see it. Okay. All right, so we really have nothing left except a hole. Okay, so I'm going to do an XY chart. And I'm going to pick a number to the left and to the right in this case of this vertical asymptote, just like we did before. So I'm going to pick to the left, which would be -6, and to the right, which should be -4. Okay. So with the -6, I get -6 plus 5. I'll just write some work right here. -6 plus 5 is -1. And then, let me just do it in my calculator. So -6 squared is 36 plus, I think I get 5. Did I get 5? 36. Yes, you do. -1/5. Yuck. But not that big of a deal, guys. So that means to the left, -6. So starting at 0, to the left, -6, and down a teeny tiny bit. That's all we need to know that branch goes in that little quadrant. Sure. The math part? Okay, sure. So I'm plugging in right? Oh, is that a -5 on top? Oh, what did I do? -6, that's a -5 on top, not a -1. Sorry, that's a -5. Shoot. -6 plus 1 is -5. And then on the bottom, that's 36. That's -36 plus 5, which is 5. We actually get -1. Yeah, sorry. Thank you for catching that. So let's just put it right there. Okay. So the left 6 down 1. Now we have to plug in the -4. So -4 plus 1. And you could do this in your calculator. I'm just showing you all the plug in. So on top I get -3. That's 16 minus 24 plus 5. So what is that? 8. -8 plus 5 is -3. So we get 1. So 1, 2, 3, 4, up 1. There is our other curvy. Now, don't forget we had a hole at -1. So, and this will happen, you'll go ahead and make your branches and then go back and put it in. Where is x is -1? It's right here, right? Where does our graph hit -1? Right there. So just drawing a circle over it, that's your open, that's your hole. That hole is saying that -1 is not part of our answer. It would have given us a 0 in our denominator. That's not allowed. So those holes in those vertical asymptotes and the horizontal asymptotes are bad numbers for this graph. They would make zeros in your denominator. Okay, that's a lot. We're going to practice these for days. Okay, so get out your page, same page as from yesterday. Same pages from yesterday. And I'm going to have them up here, so if you didn't rip it out, you're fine. Let's do a couple together. So this is D23, page 150, 17 through 20. If you didn't get your Albert I.O. done last night, you can still do it up to 1 week for half credit. So I would go in and do that, and we will have a homework check on Thursday. All right. So factor, nothing to factor. Yay, we love that. Let's organize our information. Gio, you doing this with me? Okay, there's no factoring to do. Is there anything that cancels? So, Errol, does anything cancel in this one? No. You could only do that if it was x over 2x, like with no plus or minus. Then you could have canceled the x's, okay? But the plus means you can't. So, sorry, I wasn't trying to put you on the spot. There is none, okay? Because nothing cancels. I was just, yeah, okay. Is there anything in the denominator? Yeah. So that gives us a VA